Hi everyone, this is Rakesh. Welcome to VR Computer Education. This channel helps the students to learn the computer subjects in an easy way. So to get more lecturer videos, please encourage me by subscribing, liking, sharing, commenting. Let us begin the today's class. Hi everyone, this is Rakesh. Welcome to VR Computer Education. So today class we are going to learn about important topic, that is data types. So in C programming this is one of the important topic. So let us start data types. So in the last class we have learned about variables. So now to decide what type of variable we need, so we have to use data type for that variable. So let us start the topic data types. So before, what is data type? So data type specifies the type of value is stored in the variable and size of the variable. So data type will say what type of value is stored in a variable. Suppose we have declared a variable. So what type of value you want to store in that variable is set by the data type and its size also. So variable is nothing but is a storage location, and the storage location is assigned by the compiler. So soon after declaring a variable, some memory is assigned to that variable. Who will assign? Compiler. So compiler will assign some memory location to that variable. So variable, you can see once again, variable is the storage location and the storage location is assigned by the compiler. So the compiler will assign the memory size to the variable based on the data type is declared by the programmer. So variable is the storage location where the value will be stored, and that storage location is given by whom? Compiler. And compiler also will give some memory size to the variable. How it will give the size? Based on the type of data type we declare. Programmer means we are the programmers. Those who are writing the programs, they are called programmers. So let us see now. C language supports three types of data types: primitive, or you can call primary, or you can call fundamental, or you can call built-in or basic data types. These many names. And derived data type, next type, and third one is user defined data types. So let us discuss one by one in detail. First, primitive data types. So there are four types: primitive data types, or you can call primary or fundamental or built-in or basic data types. These are all four types. Let us see one by one. First one, integer type. Next, floating point type. Next, character type. Next, void type. So these are the four types of primitive data types. So first we'll see integer type. So integer data type allows a variable to store numeric value or whole number. Simply, so a value which contains without decimal point. Suppose 2, 1, 3, 129, 139. These are called integers. The same way 1.2, they are called floating point. Say without a point, the numbers are called integer type. So integer data type allows a value to store numeric values or whole numbers. Next. So int keyword is used to write integer data type values. So to write integer data type values, we use int keyword. So the storage size of int data type is 2 bytes. So when you declare int, how many bytes it occupies memory? 2 bytes of memory it occupies. Next, here we know that 1 byte is equals to 8 bits. So 2 bytes means 2 into 8, that is 16 bits. So in byte, integer will occupy 2 bytes. So convert into bits means 1 byte is equals to 8 bits we know. So here integer occupies 2 bytes. So 2 into 8, that is 16 bits. Next example you can see. See int a. So here a is the variable or user defined identifier. We are going to decide. Int is the data type, integer data type. Now compiler allocates memory for the variable a. Soon after declaring a variable, a compiler will allocate some location to the variable a. We know that int data type size is 2 bytes. So variable a allocates 2 bytes of memory size. So this is what the compiler will do. Soon after declaring int a means integer type variable a. So variable a will store only integer values, means without points, values without points. Next, integer data type is divided into 3 types. So integer data type is divided into 3 types. So what are they? Let's see. Short, int, long. So integer data type can be declared like this: short, int, long. So the smallest integer data type is short and the largest integer data type is long. Simple. Short represents small integer value like 1, 2, 3, 10, 15, like 2 digits. Long integer value represent largest value like 100, 1000, 2000, lakhs, so on, like that. Next. So here let us see the size and range of integer data type. So short data type, size in bytes and size in bits and the range. So short data type size is in bytes 1 byte. So we know 1 byte is equal to 8 bits. So 1 into 8, that is 8. So its range is minus 128 to 127. Next, int data type size is 2 bytes. So if you convert in bits, it is 16 bits. So 2 into 8, 16. Its range is minus 327682 to 32767. Next, long, 4 bytes. So 4 into 8, that is 32 bits. And this is the range. So about this sizes and range, we'll discuss in detail further. So how you got this 128 or 127? What is this minus 32762 to 32767? What are these? We'll get further topic. Next. So note. So depend on compiler size. The size and range of integer data type varies. The above values is based on 16-bit compiler. So here we have 16-bit compiler, 32-bit compiler, 64-bit compilers. So based on the compilers, these values changes. So keep in mind. For example, you can see note 2. Based on 32-bit compiler, the values are, you can see, short. So in 16-bit, short occupied only 1 byte. So in 32-bit, short occupies 2 bytes. So your range also changed. Integer is 2, long is 4, same. So remember, based on the compiler size, the size of the data type can be vary. Next. Based on sign. See, sign means here we have positive values, negative values. Means plus means positive, minus means negative. So based on the sign, that is either plus or minus, integer data type is divided into two types. That is signed data type, unsigned data type. So remember, based on sign, minus sign or minus 123 plus 123, like that. Based on signature signs, this integer data type is divided into two types. Signed data types, unsigned data type. So let us see what is signed and what is unsigned. First, an integer value which contains positive sign or negative sign is called signed integer. In the name itself it contains, signed means it contains some symbol, either plus or minus. So the integer value which contains positive sign or negative sign, either positive or negative, both, is called signed integer. So signed integers are specified by the keyword signed. But the keyword signed is assigned or not assigned. By default, it is assigned to integer data type. See here, the signed keyword mentioned or not mentioned. So while declaring a variable, we mention or we not mention signed keyword. By default, it is signed only. So here you can see, can rewrite. So we have three types of integer data types, that is short, int, long. So they can be written like this: signed short, signed int, and signed long. Next, we'll see the memory sizes. So a signed integer uses one bit for sign and remaining for the magnitude of the number. So it occupies one bit for sign, positive or negative. So integer occupies 2 bytes, right? So in that one it will take for sign and remaining it will take for the number. Next, we'll see the size and range of signed integer data types. Same. Signed short, it occupies 2 bytes. Signed int, 2 bytes. Signed long, 4 bytes. Next, unsigned. Signed means which contains positive or negative sign. Unsigned means no sign. So an integer with no sign means it does not contain positive or negative. Those type of values are called unsigned integers. Unsigned integers are specified by the keyword unsigned. Unsigned integer range starts from 0. So signed starts from minus 128 to 127, like that we have seen. But unsigned will start from 0. So like this you can represent unsigned short, unsigned int, unsigned long. Next, the unsigned integer uses all bits for the magnitude of the number and always positive. So unsigned means always positive only. Complete memory is used for the unsigned integer data types. Next, we'll see the sizes. So you can see unsigned short 2 bytes and the range is 0 to 65,535. So here unsigned range starts from 0. Actually if you see signed, here we will get minus 65 to 533. So here unsigned will start always from 0 to this much range. Next, unsigned int, same 2 bytes, 16 bits if you convert in bits. So 0 to same. So this is unsigned. Long will occupy 4 bytes and size in bits 32 bits and starts from 0 to this much value. So this is the range and sizes of unsigned integer data type. Next, signed and unsigned declarations. So how we can declare signed and unsigned? See, first signed declarations. See, observe, this is I am showing only for the short. So we have 3, short, int, long. So in that I am showing only for short. And the remaining same. So signed declaration means, see, short A short int a. See, you can write short a means a is the variable, short is the integer data type, or else you can mention like this, short int a. Next, if you use explicitly means clear and in detail. Signed short a, signed short int a. See, all declarations are same. Don't get any confusion. All declarations are same, but writing is different. That's all. See, short a, short int a means what? Next, signed short a, signed short int a means what? All declarations are same, but what is here difference? Nothing but, see, here I did not mention signed, here I did not mention signed. If you mention or not mention, by default, if you declare like this, see, short a, it is signed declaration only, considered as signed declaration. In the explanation I said, so if you mention or not mentioned signed keyword, by default it is signed declaration only. If you mention, it is called explicit declaration. The meaning of explicit is clear and in detail. See now. See, explicit declaration means clear and in detail. So signed keyword mentioned or not mentioned, by default this declaration is considered as signed only, because signed variables accepts both positive and negative values. So that is about signed declarations. Next, we'll see unsigned. See, unsigned declarations. See, unsigned we have only two. See, if you remove unsigned, it will become signed. That's why unsigned short a, unsigned short int a. So this is explicit declaration, means clear and in detail. So this is about integer data type. So in the integer data types, we have learned integer type. Still we have float, character, void. So integer is divided into totally 4 types. Integer type, next floating point type, next character type, next void type. So in that we have discussed integer type. So in the next video, what we are going to learn is, just now I said, see how we got these ranges and sizes. So how it occupies 2 bytes, where the value is stored, we'll see clear and in detail. Just before going to the topic, just we'll revise the previous one. Integer data type is divided into 3 types. We know already, that is short, int, long. So short, int, long. Next, so based on sign, that is a positive or negative, integer data type is divided into 2 types. So this is the previous class we have learned. So if you are not understanding this, just once watch the previous topic, data types introduction topic, then you will understand this clearly. So based on the sign, means either positive or negative, integer data type is divided into 2 types, that is signed, unsigned. So what is signed? An integer value which contain positive sign or negative sign is called signed integer. So if you contain any sign, plus or minus sign to the data, means plus 1 or minus 1 or plus 2 minus 2, this is signs. If contains, then that is called signed integer. Signed integers are specified by the keyword signed, but the keyword signed is assigned or not assigned. By default it is assigned to integer data type. So if we assign or not assign, by default this signed is assigned to the integer data type. So now this can be written as signed short, signed int, signed long. Next, unsigned. So what is unsigned? The name itself, it does not contain any sign. So an integer with no sign is called unsigned integer. Unsigned integers are specified by the keyword using unsigned. The unsigned integer range starts from 0. So these are the ranges. Today we are going to see how it starts from 0, why it starts from 0. So the same way we can write this as unsigned short, unsigned int, unsigned long. Next, these are the ranges. Signed integer. Signed means contains positive or negative. Next, unsigned. Does not contain any sign. Its range starts from 0, I said. You can see 0 to 65,535 like this. 0 to 65,535. 0 to 4294967295. What is this? How these ranges are calculated? That is going to be seen in today's class. You can see the red color boxes, how these ranges are calculated. How you got? What is minus 32768 to 32767? What is this? So like this, we'll see now how to calculate these ranges. First, example, signed short. So three types of integer data types: signed, int, long. In that we'll taking signed short first. So unsigned short. Two I have written: signed short, unsigned short. So signed short occupies 2 bytes, unsigned short also occupies 2 bytes. So now we have to find the minimum and maximum values. Then we will get the range or limit of a data type. So first we need to find the minimum and maximum values. Then we will get the range or limit of a data type. So first we will find unsigned short. So first we will calculate for unsigned short. So unsigned short occupies 2 bytes. Now to find the range, first we need to find the number of bits. So it occupies 2 bytes. So next we have to convert into bits. So how? So 1 byte is equals to 8 bits. We know very clearly 1 byte is equals to 8 bits. The same way unsigned short occupies how many bytes? 2 bytes. So now 2 into 8, that is equal to 16. Now unsigned short occupies 2 bytes. If asked in bits, how many bits it occupies? 16 bits it occupies. Next. So let us take. Here unsigned short occupies 2 bytes. 2 bytes. So 1 byte all zeros. Another byte, all zeros. So here 8 zeros are there because 1 byte is equals to 8 bits. That's why 1, 2, 3, 4, 5, 6, 7, 8. Right? So unsigned short occupies 2 bytes. So let 1 byte all zeros, another byte all zeros. Then what is its value? 0 only. Now, if I take 1 byte all ones, if I take another byte all ones, then what is its value becomes? Its value becomes 65,535. So here in the first example I have taken all zeros, 1 byte, all zeros, another byte. So here you will get 0 obviously. Next, if I take all bytes 1, all bits 1, you will get 65,535. How? That is, we'll calculate now. So here 0 is the minimum and the maximum. See, range means what? It contains some starting number and ending number. Limits, if you say it contains some limit, means there is some limit, means from starting to ending, right? That is what we are going to calculate. So here minimum means 0, maximum means 65,535. The range of this unsigned short is what? 0 to 65,535. This is the range or limit. How we got? So that we are going to see now. From here onwards, concentrate well. So unsigned short occupies 2 bytes. So 1 byte is equals to 8 bits. So 2 into 8 is equals to 16. We know very well. Now listen. To calculate the range, the formula is 2 power number of bits. So 2 power number of bits. So 2 power number of bits. So here bits means what? 16 bits. So 2 power 16 bits, that is equal to 65,536. So what is the 2? How we calculate range? That is 2 power number of bits. Y's are 2. Binary means what? 2 only. 0, 1. That is why we'll take 2. Number of bits it occupies 16 bits. That is 2 power 16. Then you'll get 65,536. You may get doubt. Here I have written 65,535. There we got 65,536. How, sir? Means how we have to take like this. Can see. So we got 65,536, right? Now here we need to count zeros. Means range means starting number should be there. It starts from 0. So 0 to 65,536. So here see, we need to count 0 also. So the range or limits of unsigned short is 0 to 65,535. The count will be 65,536. Range means its starting number, ending number should be there. Starts from 0, ends at 65,535. So from 0 to 65,535, the count will be 65,536 only. If you write 0 to 65,536, it becomes larger number. So it is a wrong method. So we are including 0 also. So count 0 also. So from 0 to 65,535, the count will be 65,536. So no confusion here. Next, in the same way, if you take long occupies 4 bytes. So 1 byte is equals to 8 bits. Next 4 into 8, that is equals to 32 bits. First convert into bits. Next, to calculate the range, the formula is 2 power number of bits. So 2 power 32, you'll get this much big number, 4,294,967,296. So when you count, include 0 also, then it number range becomes this much. So here we need to count 0 also. So the range or limit of unsigned long is 0 to 4,294,967,295. The count will be 4,294,967,296. So like this, we have to take the range of data types. Next. So let us discuss a small scenario. So generally, if I ask 1 to 10, how many numbers are there? we will say 10 numbers. Absolutely 10 numbers. 1 to 10, the range is 10 numbers. Same way, if I ask 0 to 9, how many numbers are there? We say 10 numbers. So here 0 counted. So the numbers from 0 to 9 is 10. The same way we have counted like that. 2 power 16 is 65,536. When you count 0, 65,535, it becomes same example. Now, in this way, we have find the range or limits of unsigned data types. Next, we will find the range or limits of signed data types. So, to calculate range of signed data types, there are two methods. Method 1, formula. Number of bits divided by 2 means the 65,536 divided by 2 means half of. Next, 2 power number of bits minus 1. Any of the method you can use. So signed data type accepts both positive and negative numbers. So the range can be, see, like this. See, 0, -1, -2, -3, less than 0 all minus, and greater than 0 all positive numbers. 1, 2, 3 and so on. Now, signed short, 2 bytes it occupies. So we know 1 byte is equals to 8 bits. Same we have to convert into bits. These are also. Now I am using formula 1, that is number of bits divided by 2. So 2 power 16 divided by 2. So 2 power 16 value we know 65,536 divided by 2. Means half of this value is 3,270. Sorry. 32,768. 32,768. Next, see, 65536 divided by 2 means half value, that is 32768 plus 32768, that is equal to 65536. Now how it can be written? See now, signed will contains both positive and negative. So here 0. So means -1, -2, -3, 2, -3, 32,768. This is the range to 0, 1, 2, 3 and so on. 32,767 is the range. Why sir here 7? Means we have to count 0 also. Here negative number starts from -1, -2, -3 up to 32,768. But here positive number starts from 0. 0, 1, 2, 3 and so on. 32,767. So 0 to 32,767. The number will be 32,768. So now the range can be -32,768 to +32,767 because count 0 also. So this is the range for signed short. Next, signed int also same, it occupies 2 bytes. They will get same calculation. Next, signed long is 4 bytes it occupies. So 1 byte is equals to 8 bits. So 4 into 8, 32 bits. Here also same formula I used. So half of this value is 2147483648. Means half of the value. The range will be -2147483648 plus 2147483647. This is the range of signed long. So now, see, data type signed short occupies 2 bytes. When you convert it, it takes 16 bits and its value is 32768 and the range is -32768 plus 32767. Next, signed int also same. Next, signed long 4 bytes. So 32 bits. So formula calculated, we got half of the value. So half of the value means one value to the negative, another value to positive. Similarly, we see unsigned also. So unsigned, so here range starts from 0 to 65535. Like this, we'll calculate unsigned integer data type. So like this, we'll calculate the range or limits of integer data type. What is floating point data types? So floating point data types is of 3 types: float, double, long double. So float, double, long double. So let us discuss one by one data type. So float data type, first one. So float data type allows a variable to store real number or fractional numbers, nothing but decimal numbers. Integer type will not store the decimal numbers. It stores only integer numbers like 1, 2, 3. Point values it will not store. But which data type will store point values means floating point data types will store point values, decimal values or real numbers or fractional numbers. So float keyword is used to represent fractional number or real number. Next, float data type size is 4 bytes. Its size is 4 bytes. So it occupies 4 bytes of memory. Next, float is a single precision data type. So here float is the single precision data type. Means what? It displays 6 digits after decimal point. After decimal point, it will store 6 digits. Let's see the example. You can see float is the data type, A is the variable. So in the A we can store decimal values or real numbers or fractional. Simply if you write a 10, it is considered as integer. But 10.124511, these are the decimal values. After point, float will store only 6 digits. So let us see here. See 1, 2, here 3, 4, 5 and 6. 6 digits it will store. One more point. Integer will store only integer values, but float will store both integer and floating point values. So this is about float data type. Next, double data type. Same, it is also used to store real number or fractional number. We use the double keyword to represent the fractional numbers or real numbers. Next, double data type size occupies 8 bytes. Float will occupy 4 bytes. Double will occupy 8 bytes. Double is the double precision data type. Means it will display 15 digits after decimal point. So it will display 15 digits after decimal point. Float will display only 6 digits. Example, you can see double A. A is equal to 10 point. So 15 digits you can display. So this is about double data type. Next, long double data type. Same, long double data type allows a variable to store real numbers or fractional numbers. Long double keyword is used to represent fractional numbers or real numbers. Next, double data type size, long double data type size is 10 bytes. Float will occupy 4 bytes. double will occupy 8 bytes, long double will occupy 10 bytes. So long double is also a double precision data type, means it occupies 19 digits after decimal point. So float will occupy 6 digits, long will occupy 15 digits, long double will occupy 19 digits. So float will occupy 6 digits, double will occupy 15 digits, long double will occupy 19 digits. See the example, like this will declare. So these are the floating point data types. What are they? Float, double, long, double. So next we'll see the floating point sizes and value ranges with their precisions. So first, float occupies 4 byte. So we know 1 byte is equals to 8 bits. So 4 into 8 will get 32 bits, and its value range is this, and it can store 16 decimal places. Next, double, its size is 4 bytes. So 8 into 8, 64 bits, and the range is this. So to know the range or to calculate the range, you can watch the previous video, that is size and range and limits topic. Then you'll understand very clearly how to calculate the range. And coming to here, double will occupy, so we'll store 15 decimal places. Next, long double size is 10 byte, and its size in bits, so 10 into 8, 80 bits, and its value range is this, and precision, it can store 19 decimal places. So this is the topic about floating point data types. Character data type allows a variable to store a single character. So character data type allows a variable to store a single character. Single means only one character. Char keyword is used to write character data type. So to store a single character variable, we use char keyword. Next, the storage size of char data type is 1 byte. So it takes 1 byte storage size. Next, we'll see some declarations of char data type. So char, signed char, unsigned char. So in 3 ways you can declare. So example 1, char ch, here char is the data type, ch is the variable. Next, example 2, signed char is the data type, ch is the variable. See here, we know already, we have learned what is signed and what is unsigned. Let us see another example, unsigned char ch. So these many declarations we can declare to store a single character. So here, what is signed, what is unsigned, we know already, we have discussed in the previous classes. Signed means it contains positive or negative. Unsigned means no sign. Here, by default, if you mention or may not mentioned, this declaration is also considered as signed declaration. The sign keyword is mentioned or not mentioned. By default, it is signed only. Okay, so these many types you can declare the char data type. Next, we'll see some sizes, ranges of character data type. First, char occupies how many bytes? It occupies 1 byte. So in bits, if you convert, so 1 into 8 is equals to 8 bits. So 1 byte is equals to 8 bits. So here the range is minus 128 to 127. These calculations I have shown in size range or limits video. You can see there how to calculate the ranges. Next, signed char occupies same 1 byte minus 128 to 127. Unsigned char 1 byte 8 bits, so 0 to 255 its range, 0 to 255. So these are the ranges of character data type. Next, void data type. So void means empty, which has no value. Void means empty, does not contain anything. Here void is a keyword. So void, void is a keyword. Next, it is a special data type which is used only for function type. So while declaring a function, we will use this void type. The void type has no value. The void type has no value. Suppose if the function type is void, then it is does not return any value, even 0. So if we declare a function using void, so the function, if we declare using void, then that function does not return any value, even 0 also. Example, see here example, we have void main. Now main is the, can observe, main is the function name and type is void. Means the function main does not return any value. The meaning of this is the function main does not return any value. So observe carefully, the main is the function name and void is the return type. So if you use void main, so the main function does not return any value. Meaning of this. So this is about void data type. So with this, we have finished primitive data types. Let us see. Primitive or primary or fundamental or basic data types. What are they? 4 types: integer type, floating point type, character type, and void type. So these are the primitive or primary or fundamental or built-in or basic data types. So in the data types, actually 3 types, that is primitive, next derived, next user defined. These are the 3 types. In that we have completed primitive data types. The next class we'll see derived data types and user defined data types. I hope you understood the class. Derived data type is the aggregation of fundamental data type. Means the data types that are derived from the primitive or fundamental data types are known as derived data types. See, the data types which are taken from the primitive or fundamental data types. Those data types is considered as derived data types. So let us see what are the derived data types. So there are 5 types: array, function, pointers, structures, union. So what is derived data type? The data types which are derived means taken from the basic or fundamental or primitive data types. So here there are 5 types: array, function, pointers, structures, union. So let us discuss one by one data type. First, array. So what is an array? See, before starting this, I want to inform you that so derived data types we have one by one topic. So array is one topic, pointers is one topic, structure is one topic, union is one topic, next functions is another topic. So individually we have separated topics in C language for derived data types. So here we'll discuss only the definition, a small example. So when we go to that topic, we'll discuss in detail about arrays, functions, pointers, structures, unions, right? So now just only definition, syntax, small example. So array. An array is a collection of items stored at continuous memory locations, or you can say it is a collection of similar data type and shares the common name of array. Shares the common name of array. So here syntax, data type, array name, size of array. Example, int, can see int num of 5 means you can insert 5 numbers in this array. So normally normal variable and array variable, what is the difference, sir? You may get it out. So normal variable can store only one value, but array variable can store based on the array size. Remember, suppose if we did not mention 5 here, that is normal variable, it can store only one value. Here I have mentioned 5 means array size 5 means this integer array will take 5 values, will store 5 values. Next, we used character data type means this is character array. You can store 5 names in this. So that is a small difference between normal variable and array variable. So what is that? Normal variable will store only one value, but array variable will store based on the array size. So this is array. Next, function. What is function? A function is a block of code or program segment that is defined to perform a specific well-defined task. See, a function means a block of code. It contains a block of code, means opening and closing braces. Within opening and closing braces, inside we'll write some code, that is called block of code, or you can say program segment. So that is defined. Why we are defining that block of code or segment? To perform a specific task. Suppose here main is the default function that is defined in every program of C. So when we write every C program, we'll start with main function, because without writing main function, how the program will be executed? So program starts execution from the main only. So here the small example I said main is a default function. Here example you can say a return type, function name, parameter list. Return type can be anything. You can write void. Void means it will not return anything. Int, it returns integer value. Float, it returns float value. Double, it returns double value, like that. Example, you can write void add. Here I want to perform addition of two numbers like this, int a, int b. Void add means here function name. Void means return type, means add function will not return any value now if you use void. We know already void means empty. Here two variable parameters have taken, int a and int b. Next example, int add. You can see int means it return type is int, means this add function will return integer value. Meaning of this. So this is function. Next, pointers. So pointers are symbolic representation of addresses, means it stores address or memory location of another variable. So a pointer is a symbolic representation of addresses. Pointer which represents addresses, or simply you can say a pointer is a variable which stores the address of another variable. Here it is there, see, simply can say we can define a pointer is a variable, nothing but pointer is a normal variable which stores the address of another variable. So pointer will store address of another variable. Syntax, see data type. Here asterisk symbol denotes pointer variable. Here variable name. Example, here I have written int asterisk ptr means pointer variable. So if you don't mention asterisk symbol here, it will become a normal variable. If you mention asterisk, then it will become pointer variable. Next, structures. So a structure is a user defined data type in C. See, structure is a user defined data type in C. It creates a data type that can be used to group different data types into a single type. So what is that? A structure, what it will do, a structure is a user defined data type. So it creates a data type that can be used to group different data types into a single type. So normally we'll declare individual data types like int, char, float. When you group all together, then that will become as structure. Means you can group. Here struct keyword is used to create a structure. Structures are used to represent a record. Syntax, see here, struct structure name. So inside data type, variable name 1, 2, 3 and so on n. Example, if you see, you'll understand. See, now here we have grouped data types. See, char, name, address I have taken as a structure. Name, street, city, state, int, here int I have taken. Like this, you can group different data types into a single type. That is called structure. Next, union. A union is a special data type. Union is a special data type in C that allows storing different data types in the same memory location. You can define a union with many members. Union provide an efficient way of using the same memory location for multiple purpose. See, a union is a special data type available in C that allows storing different data types in the same memory location. You can define a union with many members. Here members means you can see struct union keyword we will use to define union, and union name same like structure name. So inside members they are called members. Member definition seem like data type variable 1, data type variable 2, and so on. So inside these are called members, union members. So you can define a union with many members. You can define with n number of members. Union provide an efficient way of using same memory location for multiple purposes. So here structure and union looks same, but the difference is memory allocations. Structure will assign individually, union will assign only one memory location for all the members. So when we are discussing this topic separately, union structure, there we'll discuss in depth what is union, how to create union, how to execute unions, how the memory locations are given to the unions, structures. We'll see individually. So this is about union. Now these are all derived data types. So what are the derived data types? So derived data types means what? The data types which are derived from the fundamental or primitive data types. Those considered as derived data types. So they are array, function, pointer, structure, unions. So till now we have seen what is array, just definition, syntax, example. Once again I am saying this will have individual topics. So in that, when we are discussing individual topics, we'll discuss in depth. Okay, so this is just only the introductions of those topics. Thank you. A user defined data type, in short you can call UDT, is a data type that derived from an existing data type. A user defined data type is a data type that derived from an existing data type. So from the existing data type we will derive some data types. So those data types, how we will divide, you can see. You can user defined data types to extend the built-in data types which are already available and to create own and customized data types. See here, you can use user defined data types to extend the built-in data types. So you can extend the built-in data types which are already available. So built-in data types already available like integer type, floating type, char, void, and to create your own customized data types. So we can create our own customized data types. So what is user defined data type? So user defined data type is a data type that is derived from an existing data types. You can use user defined data types to extend the built-in data types which are already available and to create your own customized data types. So we can create our own customized data types. So let us see what are the user defined data types provided by C language. Now we'll see. So there are two types mainly, enumeration and type def. Enumeration, type def. These are the two data types considered as user defined data types. Using this we can create our own data types. Let's see first enumeration data type. So an enumeration data type is a special data type. Enumeration data type is a special data type consisting of a set of named values called elements or members. So enumeration data type is a special data type contains set of named values, contains some set of named values. So those are called elements or members. It is mainly used to assign names to integral constants, which makes a program more readable. See, it is mainly used to assign names to integral constants, which make a program more readable. So enum keyword is used to create an enumerated data type. So what we will use? We will use enum keyword to create enumeration data type. Let us see the syntax. See, enum is the keyword. Identifier, any name. Identifier is created by the user. User defined. Any name you can write for the enum. Enum is a keyword, identifier, open bracket. So here value 1, value 2 and so on, value n and closing. Let's see the example. So like this, enum. So I have created some week like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. All these are enumerated data types. Here week is an identifier. Now you can see enumerated types allows us to create our own symbolic names for a list of related constants. So here it is there. It is mainly used to assign names to integral constants. See, these are considered as integral constants. For them a name is given, that is week. So like this we will define the enumeration. So enumeration is also, we have topic in the C. Here just introduction I have given. When we discuss enumeration topic, there we will see more examples and we will execute the enumeration program also. Here just what is enumeration data type, just introduction. Next, type-def data type. See, type-def is used to create a new name. We'll say alias names. Alias names, just like how we have like nicknames, example Rakesh, nickname Rocky, like that, alias names we can create. So type-def is to create a new name for an existing data type. So for an existing data type, we can give the new names using this type-def. It does not create a new data type. Remember, it does not create a new data type. Simply, it defines a name for an existing type. Remember, type-def keyword is used to give an existing name, to give a new name for the existing data type. Some other name, instead of calling int, you can call with some other name, whatever name will give, like that. See once again, type-def is used to create a new name for an existing data type. It does not create a new data type. Simply it defines a name for an existing type. Keyword type-def is used to create a new name. So type-def we will use to create a new name. Let us see the example. First syntax. See like this, type-def existing type means existing data type like int, char, float, double, long. So for that, new name. Let us see now example of type def. Type def, can see type def int vr. So here, so what is type def? It will create a new name for an existing data type. See here existing data type is int and the new name is vr. Now vr will act as a int data type. That is the meaning of type def, and that is the purpose of using type def. Now we can declare like this: vr a. Here vr is an integer data type, a is the variable. Now I have assigned value to the variable a, that equals to 10. Now you can print as usual, how we print using C. See here, the keyword type def will create vr as the new name for the int data type. So from now onwards, vr will be the new name for int data type. So in this example, you can see the variable declared as vr type. So this will be integer type. Will also behave like int variable. So this is about type def. Of data types, all the data types till now what we have discussed. Basically data types are three types: primitive, derived, user defined. First, primitive. Primitive, first integer type, floating point type, next character type. So primitive, integer type, floating point type and character type. Next, first integer type. It is divided again three types: short, int, long. Short, int, long. So based on the sign, based on positive or negative sign, again it is divided into two types, that is signed integer, unsigned integer. So let us see signed integer. So you can write signed short, signed long, signed signed short, signed int, signed long. In the same way you can write unsigned short, unsigned int, unsigned long. So these are all integer types. These are all integer types. Next, floating point type. Three types: float, double, long double. Next, character type. Three types: char, signed char, unsigned char. So these are all considered as primitive data types. Next, derived data types: array, function, pointers, structures, union. Arrays, pointers, structures, unions. Next, today what we have discussed: user defined data types. There are two types we know: enumeration and type def. Enumeration and type def. So these are all the data types of C language or C programming. So this is about the data types. I hope you understood. we'll see the size of. So it is an operator or method. It is an operator or method or predefined function. So size of is an operator. You can call it as operator. You can call it as method, or you can call it as predefined function, which is used to return the sizes. So you can find the sizes using this size of operator or method or predefined function by passing the following things. So we will pass some of them to find the sizes. So what are those things? Let us see. So you can pass variable, you can pass data type, you can pass expression, you can pass pointer, and so on. So in the size of, here it is a function, it's a predefined function or a method which is used to return the sizes by passing the following. So you can pass variable, you can pass data type to find the size, you can pass variable to find the size, you can pass data type to find the size, you can pass expression to find the size, and you can pass pointer to find the size of the pointer, and so on. So here we will find the size of data types. So to find the size of any data type, we need to use the size of function. So here how to find the data type sizes using the size of function. Let us see in programmatic style. So let us write a program. Okay, let us write the code. So hash include stdio.h void main. So we are finding the sizes of data types. So first I'll declare short, I'll write as s, int I'll declare as I. See, two variables, two data types have declared, short s variable, int I variable. Now I want to find the sizes of this short and int. So how? Printf can write size of short data type is size of short data type is. So sizes will be in the integer form. So that's why we will use %d, comma. Here we need to use that function size of s, size of s. The next same way you can write size of int data type, here I. So let us execute this and check what will be the output. Here I am writing one more line breaks. Let us check the output. So this is the output of short data type, size is 2 bytes. Int data type size is 4 bytes. So short data type will occupy 2 bytes. Integer data type will occupy 4 bytes. Suppose you want to print byte, 2 bytes, 4 bytes. Then how to write this code? Let us see that code. Simple. Here you can add byte s. Just execute and we'll check. See now. See, got size of short data type is 2 byte. Size of int data type is 4 bytes. Now if you want to find the size of char, float, still we have long, double. Let us see those. Now observe here, I did not write for float and long, double. I written only for short, int. So here in the theory part I said size of is a function. You can pass variables, you can pass data types, you can pass pointers, you can pass expressions. So here I have passed variables. S is a short variable, I is an integer variable. Now directly I will write, directly I will pass character data type. So size of char data type. So here directly you can write size of char. Next, size of float. You can directly write float. Like this. Now execute. This and we'll check the output. You can see the output. This is the coding. And this is the output. Size of short data type is 2 bytes. Size of int data type is 4 byte. Size of char data type is 1 byte. Size of float data type is 4 byte. So like this, we'll print or we'll check the sizes of different data types. Here you observe here I have used variables and data types. Two methods I have shown. You can pass as a variables, you can pass as a data types. Pointers, expressions, how to check those sizes we'll see in coming classes. So this is about size of. Next we'll see about limits of data type. Next we'll see the limits of data type. So it means we have limits.h header file. It contains n number of predefined variables. So we have limit.h header file. In that header file, it contains n number of variables. And all these variables are global variables. So what are the variables are present in limits.h? All they are global variables. So global variables means you can access anywhere within the program. C means can access from anywhere within the program. And these variables are constant. So they are global means you can access anywhere within the program. But they are constant means you cannot modify its value or you cannot modify or change its value. They are constant means fixed. They can be used means they can be accessed within the program but they cannot be changed. So what is limits of data type? It is a header file. Limits.h. It contains n number of predefined variables and all those variables are global variables and they are constants. So let us see some of them. So the following are the some of the variables to find the limits of data types. So what are they? See now. See, these data types have taken short, int, long, char. See, shrt underscore min, shrt underscore max. So it gives short minimum value, short maximum value. Next, int underscore min, int underscore max. So it gives integer minimum value, maximum value. See, in this limits or ranges topic, we have discussed this. So to get clarity, you can watch that video, limits or ranges. So we have found their limits. So what is the range? So 0 to 65,536. Like that ranges we have calculated there. So programmatic way, how to check those sizes. So these are the variables used. So long, instead of calculating manually, simply you write a program, so it will display the ranges. Just now we have seen sizes, integer, character, float, int will occupy 4 bytes, short will occupy 2 bytes, like that. Next here char underscore min, char underscore max. It gives minimum and maximum. So here, so down First, all these are signed integer types. Means it may be positive or negative. It contains both positive and negative. That's why minimum and maximum. But here USHRT max means unsigned short maximum value, unsigned int maximum value, unsigned long maximum value, unsigned char maximum value. You may get out, sir, here you said minimum and maximum, but for unsigned why only maximum, no minimum? Because always unsigned means no sign. Always it starts from 0. That's why they did not mention. Unsigned always starts with 0. That's why here I have shown you cross marks. So these are unsigned integers, variables. So let us write a program and we'll see how the limits are displayed. So let us see the limits of data type. So first here we will add header file, include limits.h, printf, first we'll find minimum, value of short data type, %d. So shrt underscore min. So shrt underscore min will give the short data type minimum value. So let us see and the output. See, this is the output. Minimum value of short data type minus 32768. In the same way, we'll try to find the maximum value. So how to write? Same here. Maximum value of short data type, that is shrt max, all capital letters, shrt max. So let us execute and we'll see. See now. Here minimum value is minus 32768, maximum value is 32767. So the range or limit of short data type is minus 32768 to 32767. So like this we'll find the limits of data type. Next, we'll check for integer data type. So what will be the integer data type? So minimum value of int data type and maximum value of int data type. Here what you will get? Int min, int max. Let's see the output. You can see minimum value of int data type is -2147483648. Maximum is 2147483647. These are the minimum and maximum of int data type. Next, we'll see this is signed, unsigned. Just here there is no minimum value, so that's why I'm removing. So we have only maximum value of, we'll check for int. So here we use %u because unsigned it is, that's why we'll use %u. So here uint_max. Let us execute. So this is the output. Maximum value of int data type, that is unsigned int data type, it is 42949672995. We'll check for short also. Here we'll write short. Here USHRT and execute. You can see maximum value of short data type 65535. So like this we'll find the limits of data types. So in this way we can find the each data type limits. So I hope you understood. Thank you.